All right, so now the way you will read the test question, like the one here, will be, okay, solve the equation. But what you're really solving for is that x, right? So your goal is try to get x. And so you, what's so funny? Is that why you think that, because I'm funny because I didn't realize what I said? Yeah, wow. Anyway, so if you want to get that unknown, all right, which is that whatever symbol it is, so you thought that, hey, can I just divide both sides by tan 2? See, hey, it works, right? Tan 2 cancel. You're left with that unknown equals the radical 3 over tan 2, right? I mean, you wish it will work out, but no, unfortunately. Because that 2 is not part of a tangent, right? And tangent has a meaning. It's not, a word, right? It's, the name of the function. So what I really wanted you to think is, to me, I'm not worried about 2x or x at this moment. So it seems that I'm just asking an angle theta such that when we take tangent of it, it becomes radical 3. Is there an angle whose tangent is radical 3? We come over here, right? And that's what you have to do in the test. Just look up and see, oh, radical 3 is here, right? The angle will be 60, right? So let's go ahead and write it down. Theta must be 60 degrees. Okay. And you know that to make it fancier, you're going to include all the possibilities, right? By adding multiple of 180, right? N times 180 degree, right? But then you realize I'm not solving for theta. And to get that symbol, right? So I realized, oh, it's not theta. It's 2 x equals 60 plus n times 180. Okay. Now again, the question is, how do you solve for x? Would it be a bit too obvious? You just divide 2 across the board, right? You get x equals to 30 degree plus. Now, what is this guy? Can I simplify it? N times 180 divided by 2. What would it be? N times 90, right? Now, how come that I didn't divide the n by 2? Could be anything, okay? So I want to point out that if this were a plus sign, n plus 180 over 2, then you divide both n and 180 by 2. That's a multiplication, okay? Now, are we done? I mean, you say you stop for x, right? So that's the x, right? If you stop at this level in a test, you'll probably get 3 out of 5 points. Okay, so the 2 more points, right? And that came from this guy, right? I know you're gonna hate the name of it. It's called restricted domain. Have you heard of it? All right, let's call it restricted range. Come on. How does that work? All right, whatever. They want x to be less than 2 pi. Positive and less than 2 pi. But I have the solution of x in degrees. Can you guys help me to translate that into degrees? So x will be greater than equal to 0 degree, right? Less than equal to, or less than, what? 360, yes. Okay, so what is the n? N is integer, right? You don't have to put down what n is. I know what it is, but you should remind me that n is nothing but 0, plus or minus 1, right? Plus or minus 2, right? All the integers you can think of. So now let me play with the value of the n to get as many solutions for x that fit into the restricted domain. Can I go with angle to 0? Say angle to 0, right? How much is x? 30 plus 0 times 90, which is still 30 degrees, right? Is that in a range of 0 to 360? Yes, right? Keep that. Say angle to 1, you're getting 30 plus 90, so 120, right? That's still in a range, right? Check. Angle to 2, so that's 130, not 130, 210, right? So x is 210, right? That's still in a range, right? So what about angle to 3? So I got that as 300, right? That's still in the range, right? Can I go with 4? No, it will be too big, right? So beyond 360. Or should I do any negative ends, like -1, -2? I mean, you can try, right? When x is -1, 30 minus 90 is negative, right? That means you screen through. I didn't go through all possible ends, but I think that I start with the easy ones, and I realized that those are the only couple of, since there are 4 of them, right, are the angles that works, right? All right. So I think if you guys ever watched the recording, I did that on probably 24th. So now if you go back and you can see how I explain it, at that time I wasn't, that because I didn't have to, but now I see since, time is very limited, so I figured that, just go with the more practical way, right? But if you go with the book way to do it, like I explained it in a recording, it's just, whatever they put over here, right? But again, like I can assure you that if you go with the degrees, right, for a problem like that, you'll be fine, right? You don't have to go with the radians. So now, if you guys okay with that, why don't you take a look at 2b. And please pretend you didn't see the solution out there, right? Let's still do the reasoning to make sure that you are really getting the reasoning behind it. Say it again.
Are we doing the 2b on the left side?
No, I'm going over the example 2b on the left-hand side. And now, since you asked, so over the weekend, you guys, you know that the test is gonna have not just the first 3 topics, right? From 3-1 to 6-1 to 6-3. You're gonna have 6-5 on it, and there will be at least 2 FRQs about solving equations, right? And I'll say that this is actually very practical. So if you're able to comfortably solving all the problems up to 5A, you should be fine. Okay, and they're not too many tricky ones. Okay, so therefore, I don't want to show you the word for the pencil problems, the one you should try over the weekend. I'm just explaining the reasoning so you can get it, better. All right, so I'm looking at the left-hand side, right, of the 2B, and again, the way you read the question is not, rushing to, the X. I'm thinking, I'm looking at some kind of angle theta. So ask yourself, what kind of theta will get you sine of it to be 1/2? Right, come over here, right? You see that 1/2 says that the angle better be 30. Okay, so I'm going to go with 30 degrees for now, right? But the catch of the sine and cosine functions is that you can tell from the first page, right, of the reference sheet, there's almost always 2 angles. So the hard one is to find the second angle. And that's when the unit circle comes in. right? So you know that I'm always going to plot a point on a unit circle, right? So that point P has the horizontal and the vertical coordinate in terms of sine and a cosine, right? So again, can you guys remind me, is the horizontal coordinate cosine or sine? So it's the cosine of sine that goes to the, okay, cosine, that will be the horizontal coordinate, right? Sine is going to be the vertical coordinate. Or cosine of x, right? The x coordinate is the p, right? Sine is the y coordinate. So in this case, the p will have an angle 30 degrees. So now my question is, would there be another point Q whose vertical coordinate is exactly the same as the P? And it's going to be 1/2. Right? P has the sine of theta, which is the vertical coordinate, to be 1/2. Right? I want another point to have exactly the same vertical coordinate. What would that point be? It will be on the other side, right? So you just go ahead and reflect the P of the y-axis, right? So this is the Q, right? And it makes the same angle above the horizontal line, right? So we've got the angle associated with the P, which is 30, right? The hard one is, how much is this angle going from positive X all the way to the Q? It better be 150. You guys all see that? Since the small one is 30, you're still 30 degrees less than 180. So now, the fancy way to put down those angles is to claim that it's 30 degrees plus n times 360, okay? Or 150 plus n times 360, okay? But you might say, wait a second, I'm not solving for theta, right? I need to get x. Okay, so now, turns out that x over 3 is theta. So now, how would you get the x in terms of those degrees? Would you say that it's, instead of dividing, you're going to multiply across the board, right, by 3? You say now x is nothing but 90 degrees, right? I multiply 30 by 3 plus n times 1080. I got 1080 by multiplying 360 by 3. And then, by the way, that's why they have that interesting number 1080p, right? 720p. Yes. Mm-hmm. Mm-hmm.
So can I just, and I figure out that 90 is what, because it's like, it's gonna give us 30 at the end of the day. It's like, whatever, do I have to do all
Good.
of that?
All right. You know what? That's actually something I'm going to address once I figure it out in a proper way. I'll get back to your concern. All right. So that's a valid question. Okay. A good question right before the test. Right. But anyway, so let's first make sure that you guys are getting all the possible angles starting from 30, right? Then you're gonna multiply by 3. The same thing here, right? So it's 150 plus n times 360. We multiply everything by 3 to get x. It will be 450 plus n times 1080. Okay. Now, you guys okay so far about x, right? So now the question is, they want x to be less than 360. Positive, less than 360. You're gonna have to go with, some number of n, right, to make sure that works out. So you come over here and say, can I take n to be 0? 0 added to 90, so 90, which is good, right? What about this guy? N go to 0, 450, too big. right? What about n equal to 1? You're adding 1080 to 90. Wow, that's even worse, right? What about n equal to negative 1? No, right? No. This guy, no, right? So somehow you see 0 works, right? For one of those scenarios, plus minus 1, plus minus 2 doesn't work. That means it just so happened that there were infinite possible solutions, but the one they actually want within that infinite domain is just one solution, 90. Okay, so now back to Juwan. So she said, I mean, you know what? I realize it's 1/2, right? So x has to be 30, right? So multiply by 3, you get 90, right? You know, or you do something similar, right? You figure out it's 90 degrees. You said, Dr. Wang, you want an angle, right? That's the only solution. There you go. That's my only solution, right? Should I get 4 credits? Now, the way I agree to work is if there's some trace that I can tell from your work, that you did realize there are multiple angles. And for some reason, you better tell me what was the reason that you go with only 30 in the first place. Then I'll feel like giving you the 4 credits. All right? But I don't think that would be that easy for you to show me in a test. Right? So there's a reason that you want to reject 150 in the first place. Okay? Therefore, I'll give you 2 points for getting the 2 angles correctly. If you already show me 1 angle, 1 point. Okay. Now, usually I'll give the 3rd point to the unit circle, or it depends on if you do show me the unit circle or if you show me the infinite many solutions, right? However you do, so it will be 1 point going to, if you don't have the unit circle, if I see you writing the answer in a funny form, then you get another point. So that's 3 out of 5, right? So 2 more points goes to your reasoning about why you pick only 90. Okay, what's wrong with all the value of n? Okay, but sometimes I do want 1 more point that's awarded at the very beginning of the of the problem, and you'll see that in the next problem. This is pretty much asking you to just go with one of the fundamental equations, right, which says sine of something equals 1/2, right? But what if that you don't have an equation that's as simple as that? You have to do something ahead of time, right? And that's going to be worth a point. Right? But simply put, I would say most likely, if you only show me that theta is 90 times 3, you get 90. Oh, sorry, theta is is 30, so x over 3 is 30. X must be 90. So honestly, I'll probably get 2 out of 5. Which is not bad. I mean, but the thing is, it could have been a lot more than that. If you, convince me that, because it's not about like, so whether you're really getting the perfect way that you want it, or whether I feel like that this must be a way, for me to force you to get to the level, that the textbook wants. At least, in my understanding is, would you be able to convince me that you are at the level of, the subject, right? And it doesn't have to be, like getting all the questions in the test correctly. If I can tell, even just by talking to you, or if you come, you do something that I observed. So the thing is, you remember that Miss Cameron was here one time, right? Or maybe a couple of times. So, I mean, technically speaking, they should observe us, right? To seriously do the observation and to give us the points, right? But sometimes, I didn't realize that there could be points just by, meeting the students in the office and doing all the things I'm supposed to do as an instructor. They saw me doing things and they give me the data points, right? So, I know that if you guys are functioning at that level of the subject, then I believe that test will work out somehow. But it's hard, right? Because I don't get to see everyone in office hours, right? That means if you need to convince me in a test, you need to put it down in writing. But how easy that is to do that in a test. Anyway, now, remember what I said, that you might not be getting an equation that's ready to go, like the one in 3A, right? How would you do that if it doesn't tell exactly what sine of x is? But if they do, right, they would have, you would have been able to get it, from the chart. But if you realize what they did was to factor the left-hand side, right? So now I think that sometimes, people might get a bit confused about the way of writing the square of sine and cosine tangent. Do you guys realize that it's the same thing as writing 2 times sine of x entirely to the second power minus 3 times sine of x plus 1? So that's a quadratic expression, right? And they wanted to factor the left-hand side. So that means, do you know how to factor something like 2 times a squared minus 3 times a plus 1? This reminds you of something in college algebra, how to factor quadratic trinomial, right? I think that the way I was referring to the method as the AC method or slide divide kind of thing, right? So no matter how you do it, maybe you learn it from your algebra 2 teacher. So at the end of the day, you're going to factor that as 2a minus 1, a minus 1. Right? But, what is a? It's the sine theta, right? It's the sine x. And therefore, you take that 2a minus 1. This is just 2 times sine of x minus 1, right? Sine of x minus 1. And then what did they do to go from the second line to the third line? Would you guys be able to tell what they did? Go from here to there. This is a product, right? The product of 2 expressions. Not to mention, it's a zero product. So there's something called zero product rule, right? Zero product principle in college algebra. It says that the only way to have a product of 0 from these 2 expressions is to have either this expression become 0 or the second expression becomes 0, or both of them are 0, right? So you'll be able to solve 2 fundamental equations, right? So you're getting sine of x from the first equation set to 0. You get sine of x equal 1/2, right? We just did that, right? Remember, sine of x is 1/2. What is x? 30 or 150, right? And then plus multiple 360. Sine of x, which is 1. And again, let me remind you, the unit circle. You guys tell me if a point's going to be on a circle where it's y coordinate, because sine is the y, right? Its y coordinate has to be 1. Where should it be that point? If the point on the unit circle must have the y coordinate to be 1, where is it? Has to be over here, right? Could it be down there? No. Distance-wise, yes, 1 unit, right? But it's -1. So in this case, it just so happens that you have only 1 angle to start with, right? So now, see what they did? They, somehow figure out these answers. But, what I wish I can see from you guys, the work in a test is you tell me, all right, from this guy, I realized that x could be 30 plus n times 360, or 150 times n times 360. Okay, so that's what you concluded from this guy. Now that guy, you've concluded that so x could only be 90, right? But still plus n times 360. Now, but you're not done, right? They want x to be in the domain. You're gonna play with the n to see that what angle is gonna fall into only 0 to 360. And it turns out that you can only take 0 for the n, right? So you have 30, which is pi over 6, 90, pi over 2, 150 is 5 pi over 6, but you're okay with the degrees. Okay. So this is like solving for 2 fundamental equations, which you are pretty good at that now. But the way to get there, right, is by factoring. You're going to get 1.4, show me the correct factoring. Okay, and that's why, typically there will be a point given to the first step, which might be the hardest. If you're so stressed out in the test that you forgot you should have factored, right? But that's why you'd be doing the prop packet during the weekend, right? You definitely want to give it a try in 3B. Is that 3B? Yeah, 3A, right? The problem on the right-hand side, right? Factor it, get to the 2 fundamental equations, write down a solution with the n, play with the n to convince yourself that you only get a couple of solutions. Okay? Sure. Go ahead. The one before? This one? Sure. All right, let me just go up. Oh, there you go. Now let's say, now if you guys can refer to my recording for March 24th, there will be a question in a textbook that I went over, which is just like 3B, right? It's the same exact problem. But at that time, I wasn't that practical about the fundamental equations. I didn't have to until that this time is not enough for us to go into too much deep into the 6.5, right? But if you go back and see how I did that in a book way, so it will be just like that. Right? You definitely want to give it a try in 3B, again, just to again play with the cosine. And guess what? Number 4, take a look at the step from here to the 3rd line. All right, so that's the original equation. They subtract the sine, right, to have everything on one side, and they factor out the sine of x. Again, factoring, right? And use the 0 product rule to find out sine of x equal to 0, right? Or tangent of x equal to 1. So those 2 are one of the 2 of the fundamental equations, right? You can definitely know how to get the x even in a general way. And then you will narrow it down to only those x's that falls into that restricted domain. Would you say that it's still about the factoring? As long as you get started with that, there's no way you can miss the rest. Okay. So again, do try number 4 over the weekend. One more, I promise. Only one more they have to do in this packet, which is 5A. But look at 5A. The equations is this: cosine 2x plus sine of x equal to 0. So if I say you will have to factor, most likely in a test, right, before you get to those easy equations. But you might say, how do I factor cosine 2x? Do you guys remember, if you have to come for the quiz, or if you're still preparing for it, there are a lot of questions at the end of the quiz saying that find cosine theta, find cosine alpha minus beta, right? You might not know what to do exactly, but what are the odds that you're not using the formula for cosine 2 theta, which is double angle, to figure that out, right? So there's no reason behind it, just use it, right? So cosine 2x, which is a double angle formula, we know that there are 3 different forms for cosine 2 theta or cosine 2x. Why do you think that go with 1 minus sine square, not the other 2? Guess what? They realize if you're going to have sine going on, once we have all the sines, right? Why would you get yourself cosine, tangent, sine, right? All in the same equation, right? So they smartly pick one of the form for cosine 2x, and they transform the original equation seems tricky to a quadratic form, which we have solved in 2a or 2b, I forgot. Right? So everything down below is the same as before. You factor, you get two fundamental equations, right? You get sine of x equal to 1/2, negative 1/2, sine of x equal to 1. Go from there, get the x in terms of those fundamental angles, right? Using a chart, put the n times 360 to it, then find the n value, right? Boil down the value of x to whatever that fits into the restricted domain. Okay, and you definitely give it a try for 5a, right? And now, again, let me put it this way. For pretty much all the problems in the test about 5-6, sorry, not 5, 6-5, you'll be fine, more than fine, if you're able to solve all the problems up to 5a. But what I'm saying that you need to be able to solve it is you need to be get it quickly down, accurately, right? And also don't miss the major steps, just in case you got it wrong and you get still most of the points, right? They're only 55 minutes, right? So there'll be 15 questions, 5 IQ, 2 questions about the equation solving. There's not too much time for you to spend on those equation solving, right? Make it quick, but also accurate. Yes. Right now, I'm looking at still 10 multiple choices, 5 FRQs, right? But you know how easy to screw up the FRQs when it comes to those equation solving, but also how easy it is to secure as many points as you can from those questions. Because you know what? 2 FRQs worth, you know, almost a half of the FRQ sections. Okay. Yeah. Okay. Which one? Which talking about? 5A? Okay. 4B. There's no 4B. Okay. 3B? This one? Oh, okay. 2B? Oh, okay. All right. So homework due on Sunday night. All right. Quiz due on Tuesday morning. Seriously, start memorizing identities because so far I see whoever you might be doing way much better than fine in my class, but so far I see that almost everyone are still sometimes missing some of the identities, right? I don't blame you, right? So it's hard because there's so many, right? So start doing it, and please at least this weekend spend some time with those problems, get it over with. Next time you see me on Monday, I'll try to even get to some of the first, couple topics, right? Just in case you might have some hard time with those identity stuff. All right, yeah, sure. Yeah, Alani?